Good day, Dr. Vidya. My name is Bhushan. I'm coming from Group 1. So, our group project title will be Minimum Path Linking Kuala Lumpur and Singapore by High Speed Rail. Next page. So, this is the discussion of the case study. There are two objectives. The first one is to design a mathematical model based on the problem learning. The second one is to analyze of results based on the proposed result. As a head of department in Prasarana Center of Excellence, a task given to provide minimum path linking Kuala Lumpur and Singapore for a high-speed rail project. So this explanation in graph theory. First will be undirected and directed graph. An undirected graph is a collection of points called vertices joined by lines called edges. A directed graph consists set of vertices and a set of edges such that each edge is associated with an ordered pair of vertices. Next will be arcs and arrows. The arcs are ordered pairs of vertices. Arrows indicate the directed edges. Therefore, the degree of vertices create a path in a graph that makes a cycle or circuit in a graph. Next will be Euler path and circuit. An Euler path circuit is a graph. It's a simple circuit containing every edge of a graph and has same first and last vertices, and continuously it is connected to each other. Its vertices will have given degrees. An Euler path is graph is a simple path containing every edge of graph that has different first and last vertices. Next will be Hamilton path and circuit. Hamilton circuit is a simple circuit that passes through every vertices exactly once and has same first and last. Therefore, Hamilton path is a simple path that passes through every vertex excellently once. Next will be shortest path is path that has minimum length. And next, the last one will be Edgar discovered shortest path algorithm is the algorithm in 1959. Next. So according to the case study, we had found out linking path from Kuala Lumpur to Singapore by high-speed rail. The concept of the stations are stated below. First is Bandar Malaysia. Why we choose Bandar Malaysia is because a reinterpretation of the confluence of Klang and Gombak rivers, which symbolize wisdom and unity of people. Next will be Bangi Putra Jaya. Why? Because it's inspired by the Islam architecture, especially of mosques and inventions. Malaysia's aspiration as a progress nation, articulated by the point arcs standing united. Next will be Seremban. It's because a modern interpretation of the local Minangkabau architecture of Negeri Sembilan. Next will be Air Keruh, designed from the image of merchantship, which symbolizes the entrepreneurship spirit of local communities. Also symbolizing Malacca's history as a strategic trading port in its heyday. Next would be more. It's inspired by the Rihal, which is traditionally used to place the Quran as students learn to recite it, symbolizing the importance of learning. Next would be Batu Pahat, which is inspired by the Kuda Kepang, a horse-like item used in the traditional dance among Javanese descendants of Johor, which aims to strike a balance between heritage and modernization. The last one would be Iskandar Putri, a stylish representation of a handshake, signifying Iskandar Putri's role as a regional city for commerce and international encounters. Next page. So the table one below shows about the part location, platform, and stops. First would be Kuala Lumpur. The station location would be Bandar Malaysia. Platform type is island and side. Type of stop is express stops, and also it has domestic stops. The next one would be QU, Sepang Putrajaya. The station location is Kampung Abu Bakar Baginda. The platform type is side, and it only has domestic stop. Next would be Seremban. The station location is Labu. Platform type is island. The type of stop is domestic stop. Next would be Aikaro. The station location is Aikaro Melaka. The platform type is site, and the type of stop is domestic stop. The next one would be Muar. The station location is Bandar Inisi Pago. The platform type is site, and the type of stop is also domestic. Next would be Batu Pahat. Station location is Pura Kencana Sri Garden. The platform type is site, and the type of stop is a domestic stop. The next one would be Iskandar Putri. The station location is Gerbang Nusa Jaya. Platform type is island and also a site. The type of stop is has domestic stop and also shuttle stop. And the last one would be Singapore. The station location is Jurong East. There's no platform type for this, and the type of stop is shuttle stop and express stop. Okay. So this 2.0 is a discussion on suitable mathematical modeling using the concept of discrete structure. So table 2 below shows created to construct a connection on a suitable mathematical modeling using the concept of discrete structure. So there are few nodes here from A to H, and we have labeled it to the cities of it. Next page. So the construction of mathematical model based on given case study. In this diagram, everyone could see the high-speed rail from Kuala Lumpur to Singapore path in the alphabet way. So for an example, A to B is 20 kilometers, A to C is 45 kilometers, and it goes up to H, B is 22 kilometers. Over on this diagram, it's the same as before, but we have changed the alphabet to numbers. For an example, 0 to 1 is 20 kilometers, 0 to 2 is 45 kilometers, and up to 7 to 6 is 22 kilometers. Next, I will pass it to my teammate, Augustina.
Hello, and I would like to present about 4.0, the development of the model into programming codes. So we have used Java program used in the program to show the implementation of the Dijkstra algorithm using priority queue. We use priority queue is for to find out the shortest path based on the priority. So this priority queue is known that a queue follows the first in and first out algorithm, but sometimes the elements of the queue are needed to be processed according to the priority. That is when the priority queue comes into play, and the output shows the shortest path of the algorithm of the node from the first node. Okay, this is the analysis that we made from the result. So just now, the every nodes, each node have the consists the each city. So this is the redrawing of the our graph. So A to B, C, D, E, F, G to H. So as the result, the previous part shows the proof of the shortest path, which is the programming codes shows the shortest path of this system. So which is from this figure, so we can know Bandar Malaysia, Kuala Lumpur, Bandar Malaysia, Kuala Lumpur to Labu, Seremban, and then it goes to Air Keruh, Melaka, and then Bandar University, Pago, and then straight away to Pura Kencana, Sri Gading, Batu Pahat, and then it will goes to Gerbang Nusa Jaya, Iskandar Putri, and lastly it will reach our destination Jurong East, Singapore. So the shortest path from the north is of this path is 248.0 kilometer. So it is easy to find out the solution using the Discrete algorithm. So the following table shows how it is analyzed using this shortest path Discrete uh, algorithm. So the weight of the edges represents the distance in kilometers between two nodes. So the initial shortest path starts from the node A to B, from A to C, and then continuously until and from the node G to node H in the graph. So the source node of this graph is A. So this is how we find the shortest path from Kuala Lumpur to Singapore. Thank you very much. I hope you understand what we have explained. Thank you, my group member, Roshan, and thank you, Doctor.